Learning about the universe reveals our place in its vastness, fostering connection and humility. Its beauty sparks creativity and curiosity, prompting questions that expand our understanding. Witnessing celestial wonders ignites awe, transcending language and culture. Exploring the cosmos enriches our lives, encouraging us to marvel at its mysteries and contemplate our existence within it. Welcome to NES 132, Stars and Galaxies, taught by Professor Flex.
Astronomy 2 covers a world outside of the solar system. It's a vast universe that contains mysteries. If you love astronomy like I do, it gives you the opportunity to expand the knowledge that you already have and challenge what you already know. Astronomy 2 covers a wide variety of topics that you will learn. From knowing what light is to the beautiful wonders of cosmology, you will learn the evolution of stars and galaxies, and even discuss the mystery of dark matter and dark energy. And let's not forget relativity. While there is much to cover, I'll be going over the basics. 13.8 billion years ago, the universe was born.
Hello mortals. Once upon a time, 13.8 billion Earth years ago, the universe was very very small, but also infinite in size, as it has always been. You might rightfully ask, what? And I'm here to explain. Imagine measuring our universe by drawing it on an infinite grid, with a spacing of 1 light year. Place Earth at the coordinates 0, 0, and say, Alpha Centauri, that is roughly 4 light years away. Having that reference, plot the rest of the universe on the grid. And this is what we call space-time. Now, look back in time halfway between now and the Big Bang. The grid now has a spacing of half a light year, but it's still infinite in all directions. By winding the time back to 1 second after the Big Bang or 1 millisecond, it doesn't matter, the spacing gets smaller and smaller, and when we reach the very moment of the Big Bang, the spacing becomes equal to 0. Which means that the distance between any two objects in the universe is 0. Thus the density is infinite, and yet, the grid is still infinite in size as well. It's an odd situation where we multiply 0 by infinity, which is no bueno. Nobody likes that, not even scientists.
How it was born is still up to speculation. However, the ongoing theory of what comes remotely close to explaining how it was born is what's known as the Big Bang Theory. After the Big Bang came inflation, and after that came light. Approximately 380,000 years after the Big Bang, the universe becomes transparent. This allowed light to flow freely throughout the universe. The oldest light is called the CMB, or the Cosmic Microwave Background. This light is extremely important regarding the Big Bang. You see, light acts in 2 ways, as a particle and as a wave. Light is how we detect colors within the visible part of the electromagnetic spectrum. You're going to learn how each of these forces affect how the universe functions. As you are all aware of, light is a source of all life, and one of those sources come from stars. Hundreds of millions of years after the Big Bang, our first stars were born, and in Astronomy 2, you will learn about the evolution of all kinds of stars. How they form and how they die all affect the universe. Stars form in a dense cloud made of dust and gas. The formation of stars begins with the collapse under gravitational forces. Gravity takes over, and through angular momentum, we now have what is called a protostar. This is a pivotal point of how massive a star will form. Depending how strong the gravity is, the accretion disk, which forms through angular momentum, will then depend on the mass of a star. If there's not enough spin or pressure, the star will fail, creating a brown dwarf. too much and it will result in a supermassive star. Depending on a star's mass, this will determine how long a star lives for. O, B, A, F, G, K, and M are spectral types of stars. These are the different spectral types of stars that have been recorded. O stars, being your more massive stars, they live a very short life, while M stars, or dwarf stars, live a much longer lifespan. In fact, these stars have yet to die, and with stars, form galaxies. You're going to learn how stars affect the fabric of space-time. Fabric being the key word. Einstein's theory of general relativity states that gravity is the result of celestial bodies weighing down on space-time itself. Take a sheet of cloth, place an object on it, and what happens? It dips down, creating a curvature. If you place a less massive object next to it on that cloth, what happens then? Well, that object will move straight towards the more massive object. This is what Einstein's theory says about how gravity acts. But if that's the case, why doesn't the Earth fall straight into the sun? The reason being is due to Earth's velocity. It orbits around the sun with enough velocity that it keeps it from moving toward the sun. Einstein proposed the speed of light is constant. No matter how fast you are going, you will always measure the light at the same rate. E equals mc squared. This is how we understand Einstein's special relativity. Objects in motion experience space and time differently. The faster an object moves, the slower time moves. As energy increases, mass increases. And now we enter the world of cosmology. Toward the end of the semester, you will tie everything you learned to understand what comes next. Does anybody know where the center of the universe is? Well, it's just in fact that there is no center. You see, there's no singular point in space where objects are moving away from, and the rate of expansion is continuously accelerating, and this acceleration is profoundly caused by dark energy. We don't know much about dark energy, but it does open up the topic for discussion. There are many theories that try to tie in or explain the universe as a whole. Has anybody ever heard of the theory of everything or the grand unification theory? After Einstein, this has been a continuous interest of study. People are consistently asking themselves how the universe came to be, trying to explain how it behaves, and the ultimate end. It's a fascinating subject to wonder about, and it's what keeps me up at night. Thank you so much for watching my presentation.
As we conclude this journey through the wonders of Astronomy 2, let's reflect on the boundless beauty and intrigue of the cosmos. From the enigmatic origins of the universe to the mesmerizing dance of celestial bodies, our exploration has unveiled mysteries that continue to captivate our imagination. Through the study of light, stars, relativity, and cosmology, we've glimpsed the intricate workings of the cosmos. Let us continue to marvel at the universe's splendor and embrace the endless quests for understanding that it inspires.